Hi, welcome to topic 2.3, Newton's third law. I know it's weird that we're talking about the third law first, but it's kind of the most basic law. Um, so what we're shifting is we talked about some of the basic, the behind the scenes stuff like with forces and center of mass and systems. Now we're going to talk about everything from here on out is really focusing on problem solving. So Newton's third law states that when one body exerts a force on a second body, the first body experiences a force that is equal in magnitude and opposite in direction to the force that it exerts. Okay, mathematically, what that looks like, is that if I have force of A on B, well, it's going to be negative F of B on A. Okay, so basically what that is saying is if I'm pushing against the wall is going to push back on me. And there's like sets of forces that actually end up being what we call third law pairs. Sometimes these are what we call action-reaction pairs, right? Because the easy way to think of the third law is that for every action force, there's an equal but opposite reaction force. That's probably the more middle school, junior high, elementary school definition of the third law. So now we're going to start talking about some of these specific forces. So when an object rests on a surface, the surface applies a force on the object that opposes the weight of the object. Okay, so something that you'll see here, right? The weight of an object is given by the equation F sub g equals m times g, right? And g is that 9.8 number, right, that we've already spoken about. So the force that opposes weight is the normal force. Now, this is not the third law pair the third law force to weight. What it is like so if I have this set of books, right, the books are going to push down on the table equal to weight. But what happens is, or the stool here, the stool is going to push up back with the same amount. So it's almost like it's like a mg coming up from the books. But if we're looking at the books themselves, that force that is exerted upward is what we call the normal force. All right. Now, when you have cables, ropes, right, in there you have what's called tension. So tension will be the opposing weight force. And sorry for the small picture, but what happens is this soldier is rappelling down, right, with a force of mg. The rope is going to exert a force up on them equal to mg, but when you look at the soldier itself or the rope, right, it's going to have a force of tension. Okay, so really what we're looking at here is what is opposing this weight force. So then with the space shuttle, you have what is called thrust. So thrust is a force that pushes an object forward in response to a backward ejection of mass by the object. So rockets and airplanes will use thrust. So again, right, I have the weight down, right, and what's happening is the thrust is what is opposing that weight, and that's what's actually causing the upward push. Okay, but again, if you do a free body diagram, you have the weight of this shuttle down, and then you have the thrust upwards. Okay. Now, what we're going to do is there's no example problem here because a lot of times when they talk specifically about third law, they're always really looking at, like, for this force, what's opposing it. So there are more multiple choice questions. They could show up on a free response question in the sense of, have you identify, right, a third law pair or a third law force. So next thing we're going to do is we're going to talk about the first law, which now begins to start focusing more on like some of these more mathematical portions of the laws.